All right, so our first video went over trigonometric substitution with sine. Now we're going to go over tangent and secant. So whenever you have an a squared plus x squared, then the substitution to make is actually going to be a tangent. You can see mathematically where that's going to be 1 plus tangent squared is secant squared, and we are going to end up with secant theta. Now we are going to be on the assumption that we are in the domain of tangent and secant, and so secant is positive in that domain, so that absolute value of the square root on the inside piece ends up just being positive. Okay, so nothing kind of tricky about that, just we're going to make this assumption just to make it easier on ourselves. Also, you want to make sure that you do use these reference triangles in order for us to do the plugins back in the end of it to make sure that you get the thetas back into x's. And then one integration technique that is just kind of like a known rule or would be given to you on a formula sheet, I wouldn't expect you to know this off the top of your head, is that the integral of secant theta, d theta, is the natural log of secant theta plus tangent theta, d theta. That takes a lot of knowledge of trig functions to know. So again, I would give this to you solving this problem, or like a little box that's like, hey, here's some trig functions to know. Same thing with cosecant theta being natural log of cosecant minus cotangent. Also knowing that like the integral of tangent is the natural log of secant. So just some of those that you might want to do some u sub for that aren't just like normal rules of just like, hey, the derivative of this is this, so the antiderivative, I know it. I'm going to go ahead and give you those. And before the exam, I'll let you guys know too which ones you will be given and which ones you'll need to memorize, okay? All right, so let's look at this example right here. In this case, I have 1 plus x squared. I don't have anything on the outside as far as an x is concerned, so I cannot do an x or a u sub here. A is going to be equal to 1. And so I can just set up this as my representative triangle for my trig sub piece. And let's let x be then, move that over, a times tangent theta. And so dx is a derivative of tangent is secant squared. So in place of dx, I'm going to have, instead of a, we need a 1 here. We know what a is. I'm going to have secant squared. And I'm going to have 1 plus tangent squared with the d theta connected there on the bottom. All right, 1 plus tangent squared is secant squared. The square root of secant squared is secant. So I'm going to have secant squared theta on the top, secant theta on the bottom, d theta, oops, secant's on the bottom, not sine. There we go. And so this simplifies to the integral of secant theta, d theta. Now again, this would be a rule that in my course I would give this to you, or you would want to go probably look this up. Like if you want to commit it to memory, more power to you, but that's going to end up being our antiderivative. But then I need to plug back in, correct? So a is 1, so tangent is equal to x, natural log of, I'll leave a little room for secant, so plus x, close, plus c. All right, what is secant? So remember, secant is 1 over cosine. Well, cosine would be 1 over the square root. So secant would be square root of 1 plus x squared. That looks really yucky. We have a square root inside of a radical, or inside of an absolute value, inside a log, like just kind of crazy, but that's going to be it. Okay, that's our answer. All right, another example, and our final example is going to be when we have x squared minus a squared inside our square root. In this case, you are going to want to use a secant as your substitution. And when you do that, you end up getting tangent. But remember, we have to have positives inside our square roots. And so you have this absolute value. Now, for our purposes, we are only going to be dealing with x bigger than or equal to a. So we're only going to have this case. You do need to be very careful with tangent because of where we have positives and negatives. And if we're going from potentially like negative sides of square root values, I'm not going to give you anything that tricky on this for my classes, but just know tangent gets a little bit tricky here. We're only going to deal with x being greater than or equal to a, okay, so that we can just have that positive side. All right, and then we got some trig sub back into this as well. One other trigonometric identity integral that I do want us to know. So we found out in that last example that the integral of secant theta was the natural log of the absolute value of secant theta plus tangent theta. The other one that I want us to have on our notes here, and again, this is one that like you would be given because this is a little bit of a beast. Looking it up on an integral chart, okay, which is what you would probably do, honestly, in the real world, is you'd look at this and be like, okay, now how do I integrate that? Okay, so the setup is on you, the steps are on you, but sometimes we look at that integral and be like, oh man, how do I integrate that? So the integral of sine cubed is 1/2 secant theta plus 1/2 the natural log of secant tangent inside those absolute values. Okay, and I'm sure there's a trigonometric substitution that gets you to that, but for the purposes of what we're doing, I would give this to you on a test, okay? A little box with all the, like, you might need to know these integrals for you to use. Okay, so if I want to find the area of the region between this graph and the x-axis from 3 to 5, just a little bit of a graph thing here. This graph looks like a square root function, and it does have a 0 at 3, and then I have all x values that are going to be greater than or equal to 3 in here. So my tangents are positive when I get to that point. Okay, but I'm going to go from 3 to 5 on that interval. On this integral from 3 to 5, I'm going to actually do the indefinite integral and then plug back in and then plug these x values in versus trying to do all of the inverse trig. In my brain, it just makes more sense that way, but I'm just going to integrate this first with all the trigonometric substitutions and then come back to this piece here. All right, so let's look at what this triangle is going to be. We have this triangle here, and it looks like our A equals 3. So here we have x squared minus 9, and here we have x on our hypotenuse, okay? All right, so I'm going to let x be equal to 3 secant theta, and that means that dx is 3 secant theta tangent theta d theta. When I do that substitution in here, I end up getting 9 secant squared theta minus 9. And then on the outside, this piece. Inside here, I end up getting 9 tangent squared theta, because secant squared minus 1 gives me tangent. I factor out the 9 to get that, and then I can take the square root of all of that inside to get 3 tangent theta times 3 secant theta tangent theta d theta. That then gives me 9 on the outside, and then tangent squared theta secant theta d theta. The derivative of tangent is secant squared. I don't have a secant squared. The derivative of secant is secant tangent, but I can't get this into a trigonometric integral like I was able to do in some of our previous material. So the best thing that I know to do is change tangent squared into secant squared minus 1, and then distribute that secant back. So that's where we're going to get that secant cubed theta minus secant theta d theta. All right, I'm going to have to use, I went a little bit too high there. I'm going to have to use this shortcut here. So I have 9 on the outside. Secant cubed gives me 1/2 secant theta tangent theta plus 1/2 natural log of secant theta plus tangent theta. The integral of secant is the natural log of secant theta plus tangent theta. And I'm going to evaluate this from x equals 3 to 5. All right, so I'm going to do a little bit of some substitution back in here. These combined are going to give me just negative 1/2 natural log of secant theta tangent plus tangent theta. So I have 9/2 here. Secant of theta, we know, is x over 3. Tangent of theta is x squared minus 9 over 3, square root of x squared minus 9 over 3, plus, negative 9/2 natural log of, we said this is secant, and this is tangent, from x equals 3 to 5. I plug in 5. I end up getting, I'm going to have to write down here a little bit, 9/2 5/3. When I plug in here, I get the square root of 16, so that's going to be 4/3. We said that was 5/2 plus 4/3 minus. Now, when I plug in 3 into my square root, I end up getting 0 here. And then minus 9/2. Natural log, this one is 0, 3 over 3 is 1, but the natural log of 1 is 0. So this piece here, after you simplify, is going to be your final answer. You do end up getting 10 minus 9/2 natural log of 3 when you simplify this.